I'm Diane Brancasio. This is Justin Schmidt. We're at the MIT
Hello.
Edgerton Center, and we're going to talk about, we're going to do sort of a live instructable on our Tilt Buzz Gizmos. And we're just show you how to make it. This is a kind of fun toy. Let's see if I have my blue fish here. So we'll just demo it here. Okay, so which camera am I on?
Here,
This one.
right here.
Okay, so here I have this fish, kind of like a flounder. So when it's flat, it's buzzing. But when I turn it up, it's not. And so what a flounder does is it sort of goes in the sand and it sort of like shakes until it gets itself in there. So I had made a couple of these and people are like, how does it do that? Do you have a computer on it? I'm like, well, no, it doesn't really have a computer. It's a lot simpler than that. So we sort of made it into a project, and a student that recently graduated decided to do it in Honduras. But so then the project has gotten a little bit bigger, so we've made it easier, or like scaffolded it a bit. So that's what we're going to show you how to make really simply. And my suggestion to you is figure out what it's doing before we talk about it. Let's see if I can get this in. Maybe screenshot or something so you can look at it, but I will definitely have it.
There we go.
Okay, am I too high, too low? There you go. Notice that one of those paper clips is just there as a foot, but this one, wait, it's over here, is a switch. I'm backwards. Okay. All right, on to you, Justin.
All right. So we're here at the MIT Edgerton Center. And for those of you that do not know us, the Edgerton Center was started in the 90s after this wonderful MIT professor, Doc Edgerton, passed away. And his family decided that his legacy at MIT should continue. So we have this amazing group of people. So actually, let me back up a little bit, talk about Doc. So here he is. He was famous for developing high-speed photography and doing underwater imaging and all sorts of funky things as an electrical engineer and a professor of electrical engineering here. And I'm not on the right screen, so it's not going to let me change slides. There we go. And so what we do here at the Edgerton Center is we support a lot of the hands-on clubs and teams like motorsports, solar vehicle, all sorts of, we have a new one that's like Minute to Win It or something, or minute trying to break it, or they're trying to break world records, all sorts of like funky things that the students are interested in. We'll find a way to support them. The other thing we do is we support this space. This is the student project lab. This was Doc's old electronics lab. And as you can see behind us, there's a bunch of goofy projects strapped to the wall. This space was essentially a maker space before the term even existed. Doc would invite students in just from the hallway and be like, hey, what are you working on? And this really became a space for students, which at the time didn't exist, a place to just come and work on stuff and find that maker community that we're all trying hard to bring to our schools and bring to our students everywhere. The other thing we do is K-12 outreach. So we do field trips mostly for local students, but we've gotten kind of a broader reach as the years go on. And you can bring your kids here free of charge to do a fun activity with our colleague, Amy. And we do our K-12 maker. So this is Diane and us. Diane and us. I'm two people now. Diane and I. And we do K-12 maker. So the point is to get teachers doing meaningful, engaging, hands-on activities with their students, specifically maker activities. Do we want to get into these slides? Probably not, right?
No, let's
we
go
want to just get right into it. Okay, so that's our little introduction. The last thing I'll say about introducing us is just that we have a website, k12maker.mit.edu. So if you find yourself here from another avenue, you definitely want to go check out our site. We have a bunch of free resources on there. It's pretty awesome.
So what I'm going to show here is just some of the basic tools and materials. So can you go to the next slide? Or should I do that?
Oh, well, once I get my mouse on the right computer, we can go to any slide you want. There we go.
Okay. So we're going to show you 4 tutorials. They're scaffolded. So the first one is basic. We're just going to we're going to have the like fireflies. That's this one here. Now, can they see this?
Yeah, I
Okay.
want to get a little closer.
Okay.
We can see it.
So this one here is just a paperclip switch. That's it. So no tilt switch. So you might want to do something easy like this. And all I'm doing is turning on. These happen to be flickering LEDs. Not sure if you can see the flicker. I can see the flicker. There you go. And so just putting this simple parallel circuit, no soldering. We're just using tape and then doing like a twist and crimp kind of thing. So at this one, then I've got the salt shaker, which is kind of fun. So this one does not have that paper clip switch. It has a tilt switch, which we're going to talk a lot about. So that tilt switch, when it's in this direction, that's when there's a little ball in it that falls down. And this is being my salt shaker. I don't know if you can see the salt is supposed to be there shaking around. And then if I turn it up, I have to get used to this. It gets,
Oh, yeah.
now it's not shaking the salt. So this is just a vibrating motor and a battery and a little tilt switch. So when I do this, that motor is starting to turn on. Okay, so that's the second one. Then we get to a harder one, which I may link it there, but it's actually not working too well. I want to look at this one a little bit better. And for this, am I still on?
Yep, you are.
For this, I have the tilt switch is controlling both the motor and the lights. And so this is supposed to be like a thunder and lightning that was going to be flashing and shaking. But for whatever reason, right now, I don't think the two are playing well together, or I should have had something better on it. So I might skip that one and then jump ahead to the really fun one, which is like the fish or these maracas. I'll show you these maracas too. I'm using a paperclip switch. And when it's in a certain position, it is buzzing and lighting. And when it's not, like laying down, then it's just lighting. So there you have two circuits that are parallel to each other. And we'll talk about that. So there's a little bit of series, a little bit of parallel going on, and you just put it together. And it's kind of cheap and easy and fun to put together.
Can people hear the vibrating, the buzzing sounds? I don't know if Zoom is gonna pick it up or not, or if it's gonna filter it out. But there's a motor that's spinning, it's making the whole thing vibrate and buzz.
Well, that's what it's making vibrate, is also because I put those little washers on it. But also when it's vibrating, notice that the lights are flickering. And when it's not vibrating, the lights are pretty solid. So I'm not sure if you can see the flickering too well.
It's showing up a little bit.
Sometimes. Yeah, there I can see it a bit more. Okay, so let's jump to the next on this
Okay,
one.
one sec, just gotta go here. Make us a little smaller so we're not blocking the screen, and then back to the slides.
Okay, here's the materials you're gonna need. The coin cell batteries, which you can buy online pretty cheap. Little vibrating motors. All of these are linked to like Amazon sites. Some LEDs, some tilt switches, which you're going to see more about on the next slide. Paper fasteners, paper clips, and some Scotch tape, cardboard, or we've been using a lot of this corrugated plastic, pretty similar. And let's jump to the next. Okay, thank you. All right, so here's the little tilt switch. It's a small piece, and I've put together like a small kit of everything in one little box, so I can do this with groups. So that tilt switch is now quite available to buy. It is, it's about 1/2 inch here. You can sort of see it. And it's got a little ball in it. That's the thing that is the confusing part, that everyone thought was like a computer that could tell what direction it was. This is sort of like the way you have a float that stops the water, in the, like for a bilge pump, you might have a switch like this, or something that tips over, or something like filling the toilet tank. There's switches like this, very mechanical switch. Now I'm showing 2 of them on here. The one that's plastic wrapped is what I see a lot of now, but when I was buying these a couple of years ago, they were aluminum on the outside. like that. And it's probably better to get the plastic wrapped ones, although they do look like capacitors. But with the aluminum ones, the center lead, when you bend it out, it might touch the outside. So you get a short circuit. Doesn't work that way.
Oh, sorry,
And,
that's
oh,
my
okay.
bad. 1 second.
Okay, just,
Oh, sure thing. Able. There we go.
okay, this is the vibrating motor. One small thing, it is less than an inch, about 3/4 of an inch, this little piece. This has a little off-center weight, and it makes everything vibrates as it spins in either direction. So it goes, it has a red and a blue wire. There's no polarity. You can just connect it either way. And these, when you buy them, I linked a source that has decent sized wires. They come with very thin wires, like 28 gauge. So you want to be try to find motors that have some pretty good wires, and probably strip them in advance for the students so that they don't have to strip them because the wires are super thin. All right, is there anything else on this slideshow?
Do you remember how much the tilt switches cost? Someone's asking in chat. Trying to,
You know what? Just let me just go to that link.
I want to be more specific than inexpensive.
Inexpensive. They're like $1 each. All right. So here is 20 of them for $8.
Sorry, fighting over the mouth
Okay.
now.
Now I'm not sure what to do.
All right, we'll go back.
Wait,
Hold
hang on. Let me go on this. I'm going to do mouse. Oh, we both have mice. Yeah.
my hands
So
off the
there's pack of 20 for $8. See if they said, okay. Now, how do I get back? Okay, same thing now with those vibrating motors. Let's just see what I have. Those are a little more expensive. Oh, 16 for $15. Not bad. There's one thing I didn't mention too much on here. That's this hookup wire, which is very flexible. It's the kind of wire that would be on your headset if you weren't using Bluetooth headphones. It's that soft, super flexible, kind of thin wire, but now it's available as 24 gauge, which is pretty nice. Most hookup wire is 22 gauge, which is a little bit bigger, but this 24 gauge wire is fabulous. It is really flexible and soft, so it's easy to fit on the back. I'm going to take a piece here and just show you some of that.
I'll use this wire too for soldering projects.
It's like, can they see this? It's
Yeah.
just really
It's
flexible. It would have been, like I said, the stuff that's on your headset that gets all tangly because it's a little bit soft, but in small pieces, it's great.
And I was saying, use it for soldering projects too, because it doesn't melt as fast as other insulation goes.
Yeah.
Hold on 1 second. I need the mouse.
And that's got plenty of wire for $16. So,
You can take it.
all right. So those are the materials. That's what we just wanted to show. And here's the tools you're going to need. Hot glue, wire stripper. The wire stripper we use has the numbers on it. I'll probably link that in because I get that one on Amazon for like $6, $7. It's gone up. And so these kind of things, push pins, small screwdriver, not for driving any screws, just for poking holes in the cardboard. And so now we're going to go back to the beginning of this. And that's where I'm going to link these other pieces. Sound good?
Gotcha.
All right. So this one here will be on the website. Link this one, and then it'll link to everything else. Actually, this whole page will probably be on it. All right. So let's go see the fireflies. Now, there's going to be a couple of spots in here that are asking me to add a picture. So you can just ignore those because I'm going to add the pictures. They'll all come in. So skipping through those first couple of slides, which shows materials, tools, I can go on to slideshow. Here we go. Then we're going to make the paperclip switch. So poke a couple of holes, put a paperclip in, and I'm going to keep showing along the way the schematic. Okay. Here I'm going to add an easier picture, but basically saying cut some pieces that are about 10 to 15 centimeters, so 4 to 6 inches, and strip them one side bigger than the other just to prepare them in advance. So 3 centimeters is just about, let's see, 3/8 of an inch. So it's about an inch. And the other side is going to be just half of that. So only about half an inch. And wrap them around. Notice I'm wrapping around the top here and then squeezing the paper, the legs back, and it makes a nice connection. Then you'll wind up with, let's have it here. If you can put this on the screen somehow.
Yeah, I'll just switch back to our camera.
Okay, so that just made this part where I had the 2 brass fasteners on the back, the wire is on the top. Sometimes you need to have 2 wires here, and sometimes you just need to have 1. So I have 1 going to the battery, which is here, and I have 2 that are going off to the 2 different devices. Okay, then here comes the, here you're gonna have to leave me on it. Well, actually show this slide, and then I'm gonna take an LED and a piece of wire. And where's my wire stripper? Oops, everything is in here. Okay. So we practiced a lot to come up with a method that was going to make a secure electrical connection without solder. So that's what I want to show you. Actually, can you switch to this?
You're on.
All right. So you tell me if it's looking like it's good. So I have my LED, and you probably know what the LED.
Hold it further down because it's
Here?
out of focus. Yeah.
Okay.
Yeah, just do it all.
So, okay.
Okay.
So also, can you get me a coin cell battery?
Yes.
I know I had them. All right. So on the LED, there's 2 sides. There's a long and a short. The long one is the positive. So keep that in mind. You can start looking at them and see also how the insides are, but I don't want to get into that now.
That's actually good.
And I can always check my LEDs like this. They'll light up one way, but not the other. So, but that doesn't matter yet. Now, for me to make this connection, I'm going to put the legs apart a bit. I'm going to take this flexible wire, wrap it around a couple of times. I could do it from one end or the other. So now it is wrapped around. I'm going to take the needle nose pliers, and in the middle of where I wrapped it, bend it over. So it's still going around it. And then, so now it's like this. And then I'm going to crimp it. Sometimes works better than others. So it should be bent like that. And then when I go to pull it, I can pull and it's not coming off. So we showed that in this slide. That's a nice way to make a connection when you're going from a soft wire to a stiff wire. You're going to need that for the tilt switch and for the LEDs. When you're going to the motor wires, you may not have to do that. In that case, you might put 2 soft wires together. So I'll just show that because we'll do the same thing. And I'll take a piece of this green wire. So in that case, to put 2 wires together, or maybe more, because I'll do that on one of these designs, I'll take them and twist them like this, twist them together. Sometimes I start them by, I'll show that again, crisscrossing them like that, and then twist them together to make sure that they are twisting around each other. Okay, once you have that, bend it in the middle with your finger or a pair of needle nose pliers, and then squeeze the whole thing together. So now I go like this. They shouldn't come apart, not with a normal amount of pull. You may be thinking, I could use a wire nut for that. You could. Those are the I don't think I see them in front of me. I'll bring them in a bit where you just twist them together, but I'm assuming you don't have too many specialized things. So it's twist them together, bend it over and squeeze it. It'll give you a good start. Okay. Can I go to the next slide? I can't.
Oh, wait 1 second. Okay, now let me bring my mouse over.
Okay.
There we go.
So this is going to show you that LEDs have different voltages they like to work at. Red and yellow, if they can see on here. I don't know if they can. Can you go to this one?
Oh,
Sorry.
no, it's okay.
I cut out the piece from the box. Red and yellow have about 2 to 2.2 volts to start. White has 3 volts, blue has 3 volts, and so does green. So red and yellow will often work together. Blue, white, and green will often work together, but I can't cross that boundary from the warm colors to the cool colors. So you want to test it. If you have a student who says, I want to put a yellow LED and in a blue one, let's see what'll happen. I'm going to test my LEDs first, easiest thing to do. All right. And then I'm going to put the blue one on. Blue one's not going on. Take off the yellow. Now the blue one goes on. Okay. Well, sure. You could figure out the resistance and I wouldn't go into that right now. Let's see if I can use a blue and a green. And always check that you have them both working individually. Blue and green are pretty happy together. If I add a red, nope, red wins. So check them all out. Can red and yellow coexist happily? Yes. I think white is not going to be too happy here. No, but as soon as I start taking away the red, then the green's starting to light up. Take away the yellow, the blue and the green are pretty happy. The white is, oh, actually it was on the whole time and I couldn't see it because it's white. There we go. So all I'm saying here is test them out. And when you're connecting to these LEDs, like I just showed you here, either do this, or if you can solder, even better. Just put them together and do a little bit of solder. All right, I'm going to go to the next slide. If you get me there, I can't.
I'm just looking at the chat. Sorry.
Okay, can you go back one?
Well, it's just I just want to address a quick thing.
Okay.
So Matt says fine motor skills question. How do younger elementary students do making this type of connection? And then Kim offers that maybe 4th grade if they've had some exposure. So just real quick, what do you think is the age range for this project? Like, what do you have in mind for that?
Well, when you're in 4th grade, everyone's got the electrical part of the curriculum. So how are they making circuits there? Maybe they're doing alligator clips and all, but this is really once I think you've maybe gotten past that initial piece and you want to put something together that is a product. I have no problem with 4th graders soldering, but a lot of schools won't let them solder. So it could be too that you just have them at least twist them there and maybe someone else can go through with the soldering. There are not many good solutions for that around. Sometimes it is just take an alligator clip, take the ends off of it and just use it to make that connection because now it's something that's squeezing it together. But if you want them to put something together like these pieces, if I wanted to do those in the back, it could be that you just, well, you can use the copper tape. It's not going to stay together. I find that's even more challenging. This connection here with the switch, that one's easy. So the idea was that this is for maybe older kids that are using it together and maybe not the first time you do it with the scrappier circuits. The student that was really enthralled by this and took it to Honduras to do with a whole bunch of high school students was, well, like I just said, was doing it with high school students. So I think it was more about an empowerment of people to do something that were low resourced versus young age. So that was really the place I was looking at it, is the lower resource.
And I think you just gotta tell it that that's a mic, right? I mean, that it's a speaker. Not that it matters.
I
And
don't
like
think it matters.
the little thing that pops up, the little weights thing. Go down to
Okay.
the very bottom.
I don't see it.
Okay, you don't have it.
Okay,
good.
I don't think I need it. All right, so let me go to the next slide. Okay, red and black wires. I'm gonna put this picture in, but basically when you look at, can I show it on here? The coin cell battery, you're gonna have the plus and the minus side. So the plus side is here, the minus side is there. There's a little black ring in between them. Make sure that the wire you put on the minus side does not reach over to the plus side, or you're just going to short the circuit. Okay, then check everything out. So for that, you're going to lay out your whole circuit. It could be looking like this right now, and check that things work before you twist everything together. So I'm saying is connect the ends with paper clips as needed. So just lay the two wires over each other, put a paper clip across them, and it will work to at least check the circuit. Okay, so the one that we just did here, let's see, this one is the first one, which was that fireflies piece that we just showed. And there's a finished product, which is here. Let's see if I can go to the next slide. Okay, I'm going to go on to the next one. Uh-oh. All right, I am going back up to the salt shaker one. Now, the only difference here is that instead of having a paperclip on-off switch, the on-off switch is the tilt switch. So you can think of it that way, but we're going to have something that at least shows the different pieces, so that if that's all you want to do, we'll have it in here. So this shows the vibrating motor in this one in particular. So I could use a motor or a light, either one. And we'll go through this, show how to do that method, and then how to connect it. So here, I'll have this, like I said, these will all be linked. And this one, we just had a little bit of delay getting all these pieces right up, but that was the next one I would say to do. So now your whole on-off switch is the tilt switch. And getting back to the hardest one here, which is that one with the fish. Okay, so what's happening with this one? This is kind of cool, because I'm going to use all the components and make something that the beauty of this was we put it in front of people and they said, how is it doing that? And I didn't particularly tell anybody until we had it, until they actually figured it out themselves. And they usually came down to wondering what that little piece was. Now, in this one in particular, that switch is hidden underneath. Oh, I see. I'm doing the wrong kind of share. Let me do a stop share. That switch is hidden underneath the fin. So you can conveniently hide stuff. And that's it. This right now is, you can kind of see the parallel circuit going on. So here's the power going to one circuit and back to the battery, and then power going to the other circuit and back to the battery. And we have a mini parallel circuit going on there too, because we put the two LEDs together. So I'm going to take you through this one on this tutorial. Let me know if you're back up and you want to take over.
I'm gonna let you just keep driving on your
Okay.
computer, but you can switch to this camera. I have it plugged into your computer.
Oh, okay. That's what you were saying.
Okay, so talking about how to strip the motor wires. See, this kind of stuff gets in my way. Sorry guys, I'm moving things that are on the window that I don't think you can see. So we're using the 28 gauge on here, so you can very carefully strip these wires. And once again, we're wrapping it around the tilt switch and wrapping it around the hard wire and then bending it over. This is one of the tilt switches that is aluminum, not covered, because I didn't have those for a little bit. Okay, so, and this, I'm really sorry about that. Here we're trying to show where this is all going on the schematic. So I have the battery going to the motor, going up to the tilt switch. Okay, I'm adding another piece of red wire off of here and then together like this so I can go to 2 places. So I have the battery, the motor, the tilt switch, and off of the tilt switch, 2 wires. The schematic is never going to look exactly like your circuit. Okay. Now I'm putting some of these wires, the one with the 2 red wires is going on to the battery, to the on-off switch, and putting them on here. So this tutorial is more of a start with one piece and keep going from there. The other ones are get all your stuff ready and then put the whole circuit together afterwards. So here's that circuit. And I'll explain why I'm doing it this way here, because I have a sample. Where was my little, it looks like this, but it has a real motor on it.
I'll take a look.
Okay. Actually, I think it's,
This guy?
no, it has a real vibrating motor, but it's okay.
I don't think the new version.
Yeah.
I don't see it.
Okay. The reason is you're going to wind up with this little piece right here, and you'll be able to test your motor and your tilt switch. Okay. Sorry, the technical stuff here is getting to me. No, I have it sitting here somewhere. That's not a problem. Okay, so here you should be able to test that the tilt switch works. Now, we had them made here. This is, let me stop the share. This is another kind of vibrating motor. I don't suggest you use them. They don't have enough power for anything. So here I was able to make my whole circuit on one piece, or maybe like this, so I can get that all working before I transfer it and then put it onto the device. So to say that again here, what I'm saying is I made all this on cardboard first, then made the nice looking model and then transferred it on. So if it's nice and sturdy, that's not that hard to do. Okay. So this step is close the paperclip switch, tip the tilt switch, test the circuit, and check both your switches. So right now the paperclip switch, the on-off should be working, as well as the tilt switch. Okay, so we have the whole first half of the circuit, and I'm going to point to this part here. You have your battery, paperclip, tilt switch, motor. This is all a series circuit. Everything is in a row, it's one series, and these 2 pieces say, I'm going to add a parallel piece to it. That parallel piece I'm going to add is the LED. So I've got an LED, and I'm just going to touch it on to those extra red and black wires. In this picture, you can see it lit up pretty bright. If I have one LED working, that's great. I can pair a couple of them together. So anytime I'm taking an LED and they're friendly, compatible LEDs, we'll say, I can just take 2 of them they will work both with their 3 volts. And of course, I'm trying to show this here. I can put the two together. Actually, that'll be in my next slide. I don't need to show it on here. And then I've got the whole circuit working. There we go. We just put 2 LEDs in right next to each other. That's it. There's your circuit. You can find the series part and the parallel part. Okay, make your object. This is an early fish. Cut it out. Now you've got this, and we're going to start adding it to it. To put the LEDs on, poke some holes with push pin and put the 2 pluses together, put the 2 minuses together, twist them just a little bit. Then you're going to add the other wire onto it. Okay, so I can test that out. Here I am putting them together. They don't look too great, but keep them separate and they're going to work because they're all twisted there. Okay, I can put that whole circuit with the switch on it or start cutting the switch piece smaller and putting everything on here is just taped on with Scotch tape. And then I can get to hot gluing it all once I decide how it's going to work. So fasten it temporarily, try it out, move things around till you get the vibration that you want, and trim the switch base if it is just a bit too large. Okay, now I'm mounting the tilt switch. That's where I'm just going to use my screwdriver, make a hole, stick it in there to get the orientation that you want. I made a fin to cover it. And this is how it's starting to look, oops, on the back. Okay, take a look at this black wire here. It was too long and too big. So cut, you can shorten wires pretty easily. Cut them and make that connection again. Or sometimes you can just twist them together like around a pencil. But this piece is somewhere in here. My original fish, I think it moved to another home in the lab or someone took it. So this here, all I was doing was cleaning it up by shortening the wires. Okay, let's get some. And okay, this one here I've already shown you, but it'll, at least I have a decent video of it on here, and I have one more good video coming up. Is the sound coming through? Probably not.
No, they should be
Okay.
here. I think.
I don't think I did a share with
That's
sound. Okay. Okay, I got this one, which we already showed you, so it's on here. All right, and then hopefully, oops, I get to my next slide. Wait, next slide.
There we go.
No, there's
Nope.
one more I put on here. Okay, I don't have it. Hang on, I'm gonna find a really cool one for you. It's there. I just put it on. Oh no, it's on YouTube. So let me just find it on YouTube right now.
Oh, yeah. This one.
Yeah, this one's really fun. Okay, I don't even know if you can see it, but you know what? I'm gonna stop share so I can get the sound in it. Can I make that a default?
I know, right? Might be a defaultable thing.
Okay, are we there?
Okay. Yeah, what do you got, Mike?
So, made a little fishing man here on his boat, and when he rocks back in the boat, he reels in, and when he settles back in, it's tries to catch the fish. Then he rocks back again, so I'll put the sensor there on the front.
Okay, folks, was that one fun or what? We also have, I have a bunch more of those. I am gonna put on the webinar page that I just had to check some permissions and if they had the kids' faces in them because the kids made some that are just hysterical. People figured out that it doesn't just have to vibrate, that it could spin something. So it was pretty good. Okay, give me some thoughts or questions, or what do you think about this? And anybody can just talk in or put it in the chat.
You have to go into teacher mode, start
I don't
calling on
know.
people.
I don't know. I want to know if anybody thinks they would like to actually do this with, and what age group they might do it with if they were to do it.
I got fun. Kim says it's fun. And awesome. I love the tilt switch and offset motors. I can see doing this in my 8th graders. Yeah, I think 8th graders could have fun with it. Awesome. Do you have the chat? Yeah, you have the chat.
I do. I'm gonna get my the guitar one.
Oh, okay. The guitar one was I'm over here. It was kind of the OG that was kicking around for a while. And it was always fun to pass it around even to did we stump Ian with this one?
Huh?
No, Ian's too smart. But we like to stump people with this. Hand it to him.
So this here, it's okay. There's the tilt switch. And I go like this. Now it's not vibrating and you go like that. And this is like, you can buy these boards. This one has a little on off switch already. So as it's just got the motor in this and put it together just to try it out. And the funny part was how many people were just like, wow, how'd you do that? And then when I did just like the little cardboard fish was also like, oh, how cool is that? I don't know, it's surprising. That's why we wanted to do it in a webinar because it seems so fun.
Miriam has a good question about like building up to this as a project. What you would do before to build some skills.
Yeah, so that's actually why we did the simple one like this. So you could hook, you could make any circuit. I would just say take the tilt switch and you could even put it on a stuffed animal and make it so that when it lies down, it's not lighting up anymore. So it's almost like it's going to sleep or it's coming up. Any of these things you could do with a bunch of alligator clips and stick them onto something else. It could be on a like hat, clothing. I think putting them on a stuffed animal so you don't see them too much. And how am I going to get them on there? Little bits of hot glue, could staple things. I don't want to get into sewing right now, but yeah, I would think that might work.
Yeah, and I think with 4th grade, you could even just take a lesson to do just tinkering, just give them some parts and some wire and some alligator clips and let them see if they can make the connections happen. I've done a lot of electronics with like younger kids, and sometimes it really depends on the kid, depending on how old they are, if they get it or not. But I wouldn't count them out for being able to figure it out. You could give them enough time and enough fun things to play with and make some circuits.
Yeah, these are the sort of the scrappy circuits version of things, right? That is the on-off switch that we just made, but then you can make it into a momentary push button. I'm upside down, where I just have to press it here because it's bent out. If you bend it the right way, let me see if I can do that. Bend the bottom down and the top up. So now I can just turn things on and off like that. But what I found in working with high school kids just a couple of years ago is that just the whole concept of the tilt switch was engaging, really, really engaging. And this circuit here, I'll show it again, is just about as simple as you can get. You would need the alligator clips but I do think you can tape wire onto the coin cell battery without any trouble. I hope that answers your question, Miriam.
That's awesome. Thank you.
You're welcome. Okay, so magnetic reed switches. Why did I take those out of my box of stuff? Because there's two parts. So I had the magnetic reed switch, and the magnets there was no way to keep them together, and they were too small, and the magnets are very hard to hot glue onto things. So unless you had bigger magnets, but the way a magnetic reed switch works is it has two pieces like this. And then when the magnet comes close, these pieces are metal and they spring together because they want to hold that magnetic field together. So they do that to make a better path for the magnetic field. So it doesn't have to jump across that air gap. So they are really cool, but hard to orient the magnet the right way. But I mean, it's nice that you can do that, but I've decided that I don't use them in basic projects right now. So we offer PD for teachers and workshops. These webinars, we're going to do 2 more electronic ones, which, do we remember what they are?
Yeah, the next one coming up is going to be light up tiles, which is a project we've done in various forms. So we're working on some new samples for that. They are, I don't know if you want to grab one or grab the board. They're little square tiles, so it's kind of taking that collage-y sort of project that you see iterations of come up again and again, and adding an element of electronics to it to make it a little fun. So it's not plugged in right now, but you've got 2 rails on the board, and then you've got magnets and some copper tape to make a circuit. So everyone that adds a tile on, it'll light up. They're really fun.
Pretty easy, and the cool thing is you can just take them off and then do another set of kids that comes in. So we have that coming up. We're doing one with the
Yeah, the one after that is going to
MP3
be
player.
a little MP3. We found these little MP3 player boards that are like $10 a board or something, maybe less. And they're awesome. Like you can control them with an Arduino, with a microbit. You can just hook up wires to it and make it make sounds. So it's a really accessible way to add quality full sounds to any project. Yeah, it'll
Okay.
be.
So I'm on my share screen, I think.
Yep.
And this is so if I go to our website and go under Teacher PD webinars, that's where we're going to be with these. So one you just saw, which will be published up here within an hour or so. This is the one coming up. Then we'll do the MP3 one. The past ones we did last fall, we did a little more digital fab. So with the vinyl cutter, this one here, which is basic electronics. So those of you saying, what else can I do with really simple electronics? This one was fun. And it's also now on Instructables. We should link that there because we just won like a first prize putting this one on Instructables. And this does not have to be 3D printed, although it's fun when it is to make an articulated, but it can also be like a simple, actually it doesn't even have to be electronic. That's it. We added electronics to it. Okay. Well, that one is now on Instructables, and it was kind of fun. We are doing an Arduino workshop this week, and electronics is coming up in maybe a week or so.
You want to show where that is on the site?
Yeah, if I can find it, sure. Let's see. No, the Zoom controls keep coming up, so I'm having a hard time moving them around. There we go. No.
Yep.
Thank you. And
yep. So Arduino is Thursday, and then next week we'll be doing 3D printing. And then the week after we have laser cutter, and then electronics will be on.
These are remote or in person. And we've been doing a pretty decent job with remote. We have not had any computers crash until today. Other things on the website, we do a lot on how to design projects to integrate with academic curriculum. And we call that program Master Making in the Classroom. We have that program going on right now. We're about halfway through it. And that's something we can do for individual districts. We will be doing it in Phoenix, Arizona in a few weeks, and that will be remote. Just drop something.
So we can even send the flies out there.
But otherwise, look for a lot of adaptable ideas here on the Create Projects page. So everything here has a 2-page write-up of some way to make these and possibly integrate with academic curriculum. So it's not just a STEM project. All this is basically to say, look around on the website. There are things about setting up and running a makerspace, choosing the right tools, selling it to other teachers and administration, and then how to design projects. And we do a bit of this in PD, but most of our outreach is published on here and on Instructables. So we thank you guys for joining us. And we've done every other webinar needing extra time. So today we said we'd go until 5:15, and now we're at 5 o'clock and kind of available for any questions that you have and anybody who wants to chat about these things.
Lots of thank yous in the chat.
We are, well, how come I can't see the chat?
I don't know.
There we go. Okay, you're welcome.
And we'll have all this stuff up soon, and we'll send something out to everyone that came to let them know. what
If you make something,
resources.
send us some things that we can put
Yeah,
on the
Catherine,
site. Just
thank
don't
you.
put any children's faces on it.
Yeah. Or put emojis over their faces, I think.
Oh, okay. So I'm gonna stay on here if anybody wants to chat. Otherwise, have a great day. Thanks for joining us. Aha, okay, if I were to buy a class set of anything to have the kids explore, what should I buy?
Fun
you-
stuff. I'm gonna let you take that. You good?
I thought you were making a list of it.
I do have a list.
Isn't that what we need?
I don't have it ready to go.
Okay,
Yeah,
we'll send you that.
Miriam, we'll send you a list. We're gonna have a really nice list ready. It's almost there. It's just quite, I have to make it not look
So-
ugly.
Yeah, if you say what should I buy? And I can go through some of these. So let's see, on our electronics, this is coming up. What you might want to do is send me your email address. But I basically have LEDs, fasteners. You need the basic tools. And I'm going to go to the electronics page and I'm going to see some of it here. And that is also where we're going to be posting it. So let's see if I go to Maker Tools, electronics. Okay, so this board has the circuit basics. Now that here demonstration board, this is a great place to start. Basically says alligator clips. Now I like to use these little lamps in holders because they are something you can dim versus an LED. So there's a bunch of stuff on here to learn electronics. This is switches and the kind of stuff you would not necessarily make something, but you would at least learn the concepts behind them. So there's the whole thing. Do I learn the concepts or do I make something? And I think they really need to intertwine. What did you just send? You sent the
The
list.
list. It's got a little more on it than just this project, but this project is listed on here.
Okay.
I think it's good. I
There-
think it's pretty up to date.
Yeah, there's a company, I don't think it is, but there's a company, Kelvin.com, that has an awful lot of really good stuff. It's like a teacher site, and I've used them a lot for electronics. I was just someplace else and I don't know where it was. Let's see. There we are. Okay, so that's on the demo. These are different types of switches, but I want to go back here. We have a few references that we use a lot about circuit components, circuit basics. So let me go to components and you're at least going to see a description of everything. So what are all the pieces without, this is not a buying guide. These are 3 different kinds of motors. These gear motors are great because you can get them to go nice and slow. These little motors, they're not very useful. They're just inexpensive. And those are the vibrating motors. There's little buzzers. You would have to decide whether or not you wanted buzzers in your classroom. That's one of those things that's really like if you want everybody buzzing. Different kinds of switches. There's that magnetic switch that was mentioned. And switches that can go to one of 2 positions. You don't need resistors when you're starting out with things like components like these. You really should not need them. But if you do get into electronics that way, you can get a color code and get resistors. Potentiometers are variable resistors that can be used as a dimmer. This is all the stuff we go over in our electronics workshop. We use this, and because all this stuff was written for that, like circuit basics and going into what are these, what is current, what is voltage, what is resistance, what are all these things, so that I know how to use it. But a lot of what we talk about is, let's say I have all these little components, how do I know what works with what? And a lot of that has to do with figuring out what voltage a component needs and what voltage a battery provides, and how can I put those 2 together to make it work. So I'm not sure how much of the question I have answered, except I do start with a bunch of these. And little motors, batteries, but then you need the tools, and the tools are under soldering. I like to have those tools. 3 volts. To the question in the chat, we are powering the tile board with the same 3 volts. Now, so I found online, so that whole piece is written up here. And I went on Amazon and found a 3 volt, 2 amp power supply. That's a lot. You might often find them with just a half an amp. What happens here and why it works with all different colors, every single LED is in parallel across that 3 volts. But I can have reds and blues and greens running. And a lot of that is because there's a ton of resistance on that copper tape. It just gets dirty and it makes a contact resistance. So it seems to work out okay. And in the different stripes, I tried to put like all the red and yellow ones on one and all the blue and green ones on another, and it seemed to work. So it's one of those things where theoretically it shouldn't work, but in practice it does. And how many tiles can I power that? I've put on about 24 and had the whole thing light up. At this point, it needs to be cleaned off a bit, but it's very easy to clean copper tape. You rub it with a pencil eraser and it actually cleans off all the mess on it. And then you should be able to put stuff back up on it. We are going to do that one in 2 weeks and also show one that has different distances. Right now, they all have the same distance on the rails, but putting 3, 4 different distances. So you might be like answering a question. It only fits in the one that it's like the 4 food groups. No, there aren't 4 food groups, but no, it could be different things that go in 4 different categories. And we're actually coming up with some projects around that. I don't know about this conductive fabric tape.
Yeah, the conductive fabric tape is cool. It's more expensive.
Is that gray stuff?
Yeah.
How much more expensive?
If you buy the Maker Tape branded stuff, it's expensive. I haven't found, granted, I haven't looked too closely, but I haven't found another source for it.
Can you use one with the other? Can you use the copper tape with the other one? Because you could use the copper tape on the pieces and do the whole board with that Maker tape.
Oh, yeah.
That might work better.
I can pull it up here. Let's see.
I just saw some in the office. That's why.
Yeah, I have a secret stash for experimentation.
Yeah.
Still haven't actually experimented with it.
Yeah, we haven't worked with that too much yet because the copper tape is just so easy to get.
Oh, wait, that can't be right.
It's probably a small roll.
No, that's okay. Okay, so I might be mistaken. I just looked it up on Adafruit. They have a generic version that's $3.95 for 10 meters, which isn't bad.
So that's pretty good.
Yeah, that's actually really good.
It's like 10 cents a foot.
All right, I'm gonna order some.
Okay. Oh, and the whole board is a magnetic whiteboard. Make sure you check off magnetic when you order it.
She's laughing because I just ordered one for our office that we thought was magnetic until we went to put something on it. It fell off.
Everything just
We're like,
falls
what?
off.
What?
Yeah, it is magnetic. This project, like most of them that we do, I saw it as an installation on a big wall and people were doing stuff. And I thought, hey, how can we do that in the classroom with a piece you could purchase?
Yeah, but it could be the side of a metal bookcase. It could be a metal door. Like you could get creative with it. Door might be hard because of the wiring, but you know, as long as it's metal.
Yeah, if you did it on a metal bookcase, would that be a problem? Because if the paint was not conductive, but you don't want the whole thing to short
Well, no,
out.
because yeah, the paint's not conductive, so it wouldn't short.
Could also just cover it with paper.
Right.
Yeah, because
right.
I've done that.
Well,
I
didn't you
took a
do one
piece,
on
I
a
did,
piece of
yeah, I
shelf?
took a piece of shelf, put paper over it, and
Yeah.
then I had it. Yeah, I thought the magnetic whiteboard was the easiest way to do it. It's just hanging up there.